sets. Håkan did a good job of revising those to make sure that there was not too much overlap with the material you've already heard from other speakers yesterday. So without any further ado, I shall hand over to Håkan.
Thank you very much. So my name is Håkan Olson. I'm Vice Chairman of Working Party 5D. I'm also employed by Ericsson, so I can enjoy the Working Party 5D meetings. And unfortunately, Stephen Blust could not be here, but we made up this presentation together. I volunteered to step in, so I could enjoy yesterday evening a Schweinefilet with a beer. Some of the slides that we originally planned to have in this presentation was presented yesterday. So we have modified it, and a new version will be uploaded, I assume, later on to the website. This was shown yesterday, but I would like to add some time aspects to this, the story of IMT. We started with task group 8.1 mid-80s and finalized IMT 2000 by end 1999 with the recommendation M.1457. That took us around 15 years. It was voice and data-centric. Then when it comes to IMT Advanced, we started that work in year 2000 after the conference, and concluded around 2012 with the new recommendation M.2012 on IMT Advanced Technologies. Around 12 years. That was very data-centric solutions for mobile broadband. Then we started the work on IMT 2020 after the WRC 12, and we will plan to finish it by 2020. 7 years. It's a very tight schedule we have for this, and we are expanding the technology into IoT this time. We have not only super fast mobile broadband, now we are also going into extremes like with massive machine type communication, smart cities, and the other extremes being self-driving cars and industry automation with critical MTC. So let's focus a little bit on the schedule. We have in Working Party 5D, we did a lot of work starting on this before the WRC 15 with the report on technology trends. We did the feasibility study, which is a good fundament to understanding what is the needs and requirements for systems above 6 gigahertz, using frequencies above 6 gigahertz. And we developed perhaps the most important document being the vision recommendation, M.2083. But we also made modifications to the resolution 56, which is describing the naming of IMT, and we added one new resolution on principles for IMT 2020, resolution 65. Now we are working with a number of documents. It's performance requirements that we need to finalize by February next year. We are working on evaluation, how to evaluate those technologies that are going to be proposed as IMT 2020. And we have related documentation to that for submission of these technologies. And we have already published circular letters calling for proposals. But these will be added with new information as we go along. And by the end of next year, we will have a workshop where there is a planning for have the proposed evaluation groups to come together and get an understanding of how we are planning to do this evaluation from the various documentation that we have developed. So up until end next year, the work is very much internal ITU process. But after the end of next year, it changes, because then we have the development of the proposals for IMT 2020. We have the evaluation performed by external independent evaluation groups, and we have the consensus building process. So then it is much more of an external in addition to the work that we have to do within the Working Party 5D. We have a schedule set up with meetings up until the end of 2020. In the last meeting in October, we did some modifications to this schedule that I would like to highlight a bit. The workshop, as I mentioned, that will be held in the October meeting next year, and we have a host for that meeting. And the plan is to have this workshop at the second day of that meeting. So it will be a 7-day working meeting with the workshop included. There is also a meeting added. It's 31 bis in case it is needed, depending on the work that we have to do in Working Party 5D. And we have also shifted, because of the now known dates for the WRC 19, we have shifted the meeting to right after the World Radio Conference. And this meeting is needed because of the evaluation process. And probably it will be a shorter meeting than we usually are having. So this is the WRC 19 agenda items where Working Party 5D have some role. Working Party 5D is responsible for one agenda item, 9.1.8, on machine type communications, and we are jointly responsible for 2. We are contributing on 8 agenda items, and we have an interest in 3 agenda items. Never before have Working Party 5D or their predecessors been involved in so many agenda items for a conference. So in addition to the work related to WRC 19 and the short time we have this time around for developing IMT 2020, the schedule is indeed very tight. Working Party 5D is divided into 3 working groups: general aspects, spectrum aspects, and technology aspects. I will shortly go through and give you some sort of status in the work on these 3 working groups. Starting with general aspects, here we have the work on the agenda item where Working Party 5D is responsible, working on IMT use in various vertical industry sectors, and then also on the agenda item itself, or the CPM text. We have started working on one document, IMT by other industries, and as this develops, there might be so that we focus on certain areas in this document with additional standalone reports, depending on the amount of material that we get on this aspect. And also, of course, we have to develop the CPM text. When it comes to spectrum aspects, we have, as was mentioned yesterday also, several important and critical areas to develop material for. Is the spectrum needs. Here we have developed documentation. We are working on one application-based and one technical performance-based approach. And in addition to that, we also have some information from some of the member states and their views on the spectrum needs. Then also we have to develop the technical and operational characteristics, including protection criteria. Both this and the spectrum needs have to go to the TG51, as was also mentioned yesterday. Here we have material developed, and we also have a recommendation on modeling and simulation of IoT networks that is going to be up for approval in the upcoming Study Group 5 meeting later this month. So this is in the spectrum aspects. These are the different areas where we are working now on and started developing material. We have the sharing parameters and spectrum needs to be finalized in February. Several other sharing studies that needs to be done, issue 9.1.1 and 9.1.2. That has to be finalized before August 2018 for the draft CPM text. We have then, as mentioned, the machine type communications, developing CPM text, and other items that I mentioned earlier where Working Party 5D is contributing or interested. There are also other work that we need to do, not the least mentioned in Resolution 223. We have sharing studies to be done there, and we have also frequency arrangements for the bands identified at WRC 15 and the update then of the recommendation M.1036. And the plan now that was revised in the previous meeting is to finalize this in October 2018. We also like to mention and highlight that we have started the joint meetings. We have had one joint expert meeting with the working parties of Study Group 3. That was held on June 20 this year. And this meeting helped to clarify issues related to appropriate propagation models and use in sharing studies. This work is ongoing, and it's planned to be finalized, as was also mentioned yesterday, before the deadline for TG51. We have also had a joint expert meeting with Working Party 4A. That was held on the previous meeting in October, and actually on October 5, and a number of key topics were discussed in this meeting. And there are four listed here on this slide, where you can see that there's agenda item 9.1.2 and 9.1.9, where we have FSS in the 50 gigahertz band, and a number of frequency bands with FSS as well, and also a document that Working Party 4A has started to work on. When it comes to technology aspects, working group, here we have issued the and also some more information about the submission and related requirements for criteria on the evaluation process. When it comes to the requirement, the technical performance requirement, and that document, we have the 8 capabilities that we saw yesterday from the vision recommendation M.2083. In addition to those 8, we have agreed on 5 additional requirements that are spectral efficiency, 2 of them, and reliability, mobility interruption time, and bandwidth. So in total there will be 13 requirements. We have a fairly stable text for those, the identification of those parameters, and also values on most of them. But there are some final agreements needed by the February meeting. But it looks like a fairly stable document already now. Yes, as mentioned, we now have 13 minimum technical performance requirements, and this up then for the February meeting. To conclude, the scope of IMT 2020 is much wider and broader than we did with the previous technologies. Now we are entering new areas with machine-type communications. Some solutions already exist especially for massive machine-type communications from IMT Advanced, but there is a need to enhance those further and also include critical machine-type communications. The time schedule is very tight, as I mentioned, both then for technology aspects to be finalized by year 2020, but also a lot of contributions expected from Working Party 5G towards the conference 2019. And important that the relation to external organizations is very important, and this cooperation with the 5G stakeholders is a key point for the work in Working Party 5G. In addition, we believe that IMT 2020 can be a cornerstone for the UN's Agenda for Sustainable Development to 2030. Thank you very much.
Thank you, Håkan. So it seems on the standardisation side, there's very similar time pressures to the ones we're facing on the spectrum and coexistence side. Are there any questions for Håkan? Okay, seems there's no questions, so thank you very much. So our next speaker comes to us from 3GPP. Dino Flore is our next speaker, and he chairs the 3GPP RAN group. On the subject of this presentation, he's looking at the 3GPP aspects, and the main features being defined for the evolution of LTE and the initial plans for 5G standardization. So over to you.
Thank you. Thank you. Good morning, everyone, and sorry for my voice. It's terrible. I'm a bit sick this morning, but that's okay. So with this presentation, I wanted to give you an update on what we are doing in 3GPP. Dino Flore, as I said, and I chair the 3GPP RAN, the technical specification group in charge of the radio technologies for 3GPP. And today I'll give you a presentation on what we are doing on the LTE evolution of 5G. And I think it's important also that we keep in mind that, of course, 5G is coming soon and will be great. But LTE evolution is quite strong and continuing for a while, and it will provide, it will address some of the initial use cases. For example, for some verticals, we don't expect right away that will be addressed with the new radio we're developing, but they will be initially addressed by LTE evolution. So it's important to see the full suite of technologies we are developing and how they will serve all these use cases we are talking about in the short, medium, and long term. So with that one, so again, the main thing of this presentation is to show how we are expanding the LTE platform to new services and new verticals, which will bring new opportunities to our ecosystem. And at the same time, we keep increase the efficiency of the platform, because we had to still cope with this tremendous mobile broadband demand and ever increasing. So we need to keep improving the platform for mobile broadband as well, while expanding it to new verticals. But as I said, and as everybody knows, we have started a lot of work on the next generation cellular technology, which we call 5G, which will address the expanded connectivity needs of the future. So, and I'll give you a gist of, in both areas, what are the main developments there. So on the LTE evolution, so focusing only on the areas where we're expanding the LTE platform in a significant way. Of course, we're doing a lot of stuff, but I just picked few items here which show you how we are significantly expanding the LTE platform. One major expansion we have been doing in the last year or so is the expansion, so allowing our platform to offload to unlicensed spectrum. So what we realized that has become a necessity for 3GPP operators to deliver advanced services and user experience on licensed spectrum, but at the same time to opportunistically offload, use unlicensed spectrum to offload opportunistically some traffic. So we have made a lot of enhancements to the LTE platform to make this possible. In particular, there are two family of technologies we have been developing to enable operators to offload traffic in a licensed spectrum. One is the LTE WiFi interworking, which will allow 3GPP operators to offload traffic to Wi-Fi, to native Wi-Fi, via this tight LTE WiFi interworking. And at the same time, we have developed a new technology, which is a modification of the LTE waveform to allow operation in a licensed spectrum itself, and we call this license-assisted access, which I will explain shortly after what it means. So for LTE Wi-Fi interworking, so just to be clear, so we kept working on interworking between LTE and Wi-Fi technologies since the beginning of release of LTE, and we have added tighter and tighter forms of interworking in the different releases. Now in release 13 and now 14, we went all the way to do some tight interworking at the radio level, which allows fast switching between the two technologies. And this was possible with these two technologies we developed. One, we call it LWA, LTE WLAN aggregation, in which we are actually aggregating the radio links from LTE and Wi-Fi. In release 13, we did that for the downlink. In release 14, we are doing that in the uplink as well. And then the second technology was LTE WLAN radio level integration with the IPsec tunnel. We call this LWIP. This is not aggregation per se, but it's a mechanism that allows us to quickly toggle between the two radio links at the radio level and serve the user with the best possible link at all time, and while also reusing existing Wi-Fi infrastructure. So you don't need modification to Wi-Fi, as opposed to the LWA framework, which for obvious reasons require some modification to Wi-Fi. So LAA, as I said, is the second option we are providing in 3GPP operator, and here we are modify the LTE waveform to operate in a licensed spectrum. As you know, the unlicensed spectrum has different requirements which we need to fulfill. Probably the most famous one is the introduction, which we had done, is the introduction of the so-called listen before talk framework, which is this politeness mechanism which allows 3GPP to share the spectrum efficiently and optimally with Wi-Fi and other incumbent technologies. Of course, Wi-Fi is the main incumbent, but there are other technologies as well in this spectrum. So we call it license-assisted access operation because what we have done is we have done a framework in which, at least in release 14, release 13 and 14, we have developed a framework in which a primary cell, the link is anchored on a primary cell which still goes on the license spectrum and allows us to deliver critical information and guarantee quality of services. And we do have a secondary cell which we do aggregate with the primary cell to opportunistically boost data rates in addition to the primary cell. So that's and that's why we call it license-assisted access, because the unlicensed part is a secondary link anchored still on the first primary link in the license spectrum. So in release 13, we did only the downlink LAA operation. In release 14, we are doing the uplink as well. In release 13, we have concluded the design, the feature design. We have now working on the a very important aspect, which is also the coexistence test. So, which is not what we used to do in the past, but of course, given that here we are sharing with another technology, so we have not only we have introduced this coexistence features like listen before talk, but we want to make sure also that we test the technology in these multi-node test environments, in which the idea is to throw some nodes in the testing environment, then replace some of them with the Wi-Fi, and make sure that LTE will not impact Wi-Fi more than another Wi-Fi neighbor system. So, and that's something we are completing right now. So we had all this happen with also an extensive dialogue with other industry stakeholders, namely IEEE and WFA. So cellular IoT, another great opportunity is, of course, there is this promising IoT market which is emerging. And to do that, we have defined three sort of frameworks, three technologies, tracks in 3GPP. One, we have enhanced the LTE version with further LTE enhancements for machine-type communication. We have also developed a new radio, new narrowband radio mode of LTE, which is optimized for the low end of the market, and we call that narrowband IoT, which runs 200 kilohertz, and it is also very suitable to refarm GSM. And then there was also some demand to also enhance GSM to be able to serve some IoT markets, because in some countries, still GSM is the only, in some geography, GSM is still the only game in town. So it was felt that there is also opportunity for having IoT services based on GSM in these geographies. We are done the first version in release 13 on this technology. We are doing enhancements on release 14, adding more position enhancements, support for multicast, mobility enhancements, and other advanced features. So there's quite great amount of interest, strong amount of interest in this area. So it's quite a promising area, I would say, with also network launches being announced, at least for the first two of this technology. So it's quite seems quite successful. So here, slide 8, it was just a chart to give you a small kind of feeling of the difference between the three, in case you were wondering. So I explained the bandwidth before, but there are other differences between the two, especially in the data rates they can achieve, the ranges, and the deployment scenarios. So, but you can look at it in slide 8 if you're interested, or ask me further later. Another interesting technologies we are doing is we are also expanding the LTE platform to serve V2X, where V2X stands vehicular to anything, like vehicular to vehicular, vehicular to pedestrian, vehicular to infrastructure. And we are doing enhancements to the LTE platform so it can serve this also promising market, which is having a lot of interesting developments, as you may know. So in our view, what we are working on is these two complementary transmission modes. One is direct communication, building on the LTE D2D enhancements, device-to-device enhancements, which we did in release 12, and we are improving that to serve the B2B scenario, but also some network communication aspects which enable broadcast of messages from a B2X server to vehicles and other actors in the thing. So we have finalized an initial version of the standard in September. We'll have a broader framework, B2X framework, finalized in 2017. But that's also a very promising area which we are working on. Slide 10. So this is also quite a big change we are doing, and I think it was worth mentioning here. So, of course, you all know that the new radio, the 5G, will have broader bandwidth, tighter latencies, so on and so forth. But we are also doing quite a significant change to the latency of LTE. So there is an ongoing item in which we are significantly improving the LTE latency, and this will allow at the same time to improve performance and user experience for existing service, but at the same time enable new delay critical services. So I want to stress that shortening the latency in a significant way is quite a big change. So it's a big investment also of our community to have this big change to LTE being done. And of course, later we will also do the 5G ANR version, so that will be important. But there is also a short-term need we need to fulfill, especially for these new areas and verticals we are serving, we are planning to serve. So that's an important thing to stress. This concludes this, let's say the few areas I wanted to show, like major work we're doing or major expansion of the platform. But a lot more things are going on. This is just another list of other projects in which we are evolving the LTE platform. So there are plenty of them, more MIMO, more capacity, more things. So, but this is pretty much business as usual. So I wanted to zoom in on things which can significantly expand the platform before. So with that, I move to the 5G again. So this is the work instead we are doing to address the connectivity needs for the next generation. First of all, we will provide a submission. Håkan before was presenting the ITUR process and IMT 2020 process in ITUR. We will, of course, will be a main contributor of that process, and we are making plans so that we can be there and be with a very good technology submission. So we have already decided to what we are going to submit to IMT 2020 will include both the new radio we are developing, which we call ANR, which probably most of you have heard about it, but at the same time LTE as well. So we will have a package to be submitted to IMT 2020. We will submit the details on whether this is done in a single formal submission or multiple ones, but that's something we will address later. On the other hand, the ANR will eventually address all the identified requirements and use cases. The reason for this last bullet is because, as I said before, in the short term, some of these verticals, some of these use cases could be well served by these evolutions of LTE, which we are doing, like in the machine type communication or B2X communication, but eventually we'll also move those use cases to NR in the mid to long term. So, slide 14. So we have made some decisions on the timeline of our 5G efforts. So we have decided there will be two phases for the normative work. The first phase will be completed in September 2018 in release 15, and this will be the first release of the NR specification, in which we are going to fulfill these short-term commercial needs which are emerging in the market. And then we will do a second release by March 2020, release 16, for the IMT 2020 submission. In this case, we will address all the needed requirement and use cases by ITUR. Well, at least the minimum criteria defined. Of course, this does not align 100% with the ITUR submission date. So our submission will come a little bit earlier than March 2020, I guess. So we'll come towards the second part of 2019. So we understand that. So our release will finish March 20, but the submission actually, as you have seen from Håkan presentation earlier, will be done sometime September, December 19, if I understand correct. And we will have that submission for that time. So a key requirement which we have established together with the phasing is that we need to make sure that the platform, the NR platform, is forward compatible at its core. And that was an important requirement, and actually is a novelty, at least in the 3GPP world, having a forward compatible framework. Because of course, to a certain extent, 3GPP the 3GPP platform has always been forward compatible. We keep adding stuff, and it's forward compatible. But this time, it was much more strong, the requirement. So we said at the core, at the physical layer, we want to make sure that there are holes so that we can inject other technologies, other waveforms, other radios in it in an optimal way in the future. So we don't have to hack the platform like we've done in the past. So not forward compatible in general, but forward compatible at its core, at the physical MAC. So that's an important design requirements which the working group are try to fulfill. We have, for release 15, as I said, the first release of the specification, we have a little bit more detailed work plan, which we have created, the different TSGs, and this has a set of milestones and the steps which will allow us to deliver in 2018, as what I said is the first release of the NR 5G specification. We also have some initial targets as we refine what we want to do in release 15. So we have identified two main deployment scenarios. One is what we call non-standalone NR deployment, and one is standalone NR deployment. In the non-standalone means that the link will be anchored on LTE, and we will use the NR, the new radio, on a supplemental carrier to boost the data rates. We have, of course, discussing different architecture options are being evaluated. We will decide which architecture option to standardize between December and March 17. The use cases of focus, as I was saying, for the first release of the specification, we are focusing on enhanced mobile broadband and some latency and high reliability capabilities. So keep in mind that this relates to what I was discussing before, that in the short term, some of these other use cases will be served by the enhancements we are doing to the LTE platform, which, as we said, the NR plus LTE will be part of our submission to ITUR. So in that sense, that is the way we are addressing the whole opportunities in the short term. So the frequency ranges, we are going to look at both below 6 gigahertz and above 6 gigahertz for the first thing, and the forward compatibility not only in the physical MAC layer, as I said before, but also between the scenarios that have been developed. In terms of actual work plan and what things we are doing, so we are completing a study in the RAN group, the radio group, on the scenarios and requirements for next generation access technologies. This will be finished in December, and we are going to send our requirements to ITUR for consideration. So that ideally we should try to align requirements and not, but of course companies are more or less the same, so we are more or less aligned. We have developed a new channel model for the frequency above 6 gigahertz, which is a novel domain for us. We completed that in 2016. At the same time, we have started the evaluation of the technology solution for to fulfill the requirements we established. The target completion there is June 17 for the end of the release 15, what we call SN.1 freeze. So the system groups in 3GPP, so they've been developing also on their side. The SA1 group has been developed the service requirements for the different family of use cases, and these are provided in the technical reports mentioned there. And now they are started the normative work to standardize those requirements in the technical specification. The architecture and security for next generation is also being developed by the SA2 and SA3 groups. Also, this is ongoing and will complete in 2016. And with that, I conclude this presentation. I don't know if you have questions.
Thank you, Dino. Are there any questions on that? Over there, Michaela, please.
Yeah, thank you, Mr. Chairman. Just very quickly, will the NR support some broadcasting like EMBMS, or is it for phase 2?
Yeah, not release 15, yes. It will be for... So broadcasting is one of the things is not in the first release of the ANR.
And a question over here.
Yes, good morning. My name is Thomas Weilacher, working with BNetzA. I have a question regarding the unlicensed spectrum. So I have taken from your presentation that, for example, the radioland bands could be used for providing additional download resources based on LTE. So here I would say, because the radio lands which are used at home, for example, typically are based on IEEE technology. So I'm not sure whether you have a view how the coexistence between different technologies in the same band could be ensured. And I think it's maybe more challenging also if we consider the automotive area, because here also we have a coexistence issue, I would say, but we also have an interoperability issue, because if you, for example, consider vehicle-to-vehicle communication, interoperability is very important. So do you have a view how this could be ensured if we have, at the end, completely different technologies in the same band?
Okay, so the question is quite relevant, but it's quite big. Let me try to unpack it. The first part of the question is, do we have a view on how LTE will coexist with Wi-Fi deployments? That is yes. So the main theme of the LAA development in the standards, we did a study first and a work item, study phase and then normative phase. So we did was a long development, and we did a lot of interaction also with the industry stakeholder involved, was around the coexistence with Wi-Fi. Because of course there are other incumbents, but Wi-Fi is the main incumbent, so we really focus on that. So all the study was to how do we modify the LTE waveform so that it can coexist with Wi-Fi. So at the end, we settle on a set of measure coexistence mechanisms, and probably the most important of them is the LBT scheme, listen before talk scheme, which is this polite mechanism that will allow to coexist with Wi-Fi. Now, to give you even going one step further, when we evaluated the listen before talk schemes, we evaluated multiple type of listen before talk scheme. At the end of the day, for technical/political reasons, we settle on a listen before talk scheme, which is very similar to it's a Wi-Fi-like listen before talk scheme, which is the mechanism Wi-Fi uses for coexisting between themselves. And that, as I said, was partly technical, partly political, whatever. But that gives you an extra level of confidence that LTE should be coexisting with Wi-Fi in a good way. So we are not done yet. We are, as I said, we are still developing. Not only we put this in the design, but we are going one step further, which it doesn't exist today, neither in Wi-Fi world nor in 3GPP world. We are developing this multi-node test to make sure that, okay, not just because you have an LBT mechanism in the spec, that you are safe and you trust that it will work, but to make sure that we do test in these multi-node environments whether we are coexisting well with Wi-Fi and what implementation coexists well with Wi-Fi or not. Because reality is that if you check actual implementations, even today in Wi-Fi, so the coexistence is all over the place. So we want to make sure that there is some sort of test which also makes sure that we also select good implementations from LTE side. We don't want a lousy LTE implementation to coexist. So I think I have a good level of confidence with the coexistence with Wi-Fi for this broadband scenario. Now, then you asked about the vehicular, and of course, this we have started. This we don't have an answer yet. We have started to discuss and to look at coexistence with the existing technology, in this case 802.11p, but we have not made a determination yet. So I guess Nils is also here. He can give his view of the so. And when you say coexistence, I assume you mean co-channel coexistence, which it's a challenging thing. And again, we don't have a resolution on that. We are studying the problem. Of course, other form of coexistence exists, which means adjacent channels. You can partition the spectrum, but this one we don't have a determination or a solid answer that I can give you. Now, more in general, it's important because more in general, it's important in the future more and more for efficiency reasons. Spectrum sharing in the different use cases can be vehicular, can be residential, can be broadband. It's becoming more and more important. So we have to always find good ways for different technology to share spectrum. So I think these developments are quite interesting because they go in this kind of trend. And if you want to add to that, there is this interesting development in US as well for the 3.5 band, in which also there will be a sophisticated, well, at least more sophisticated than what you have today, way to share spectrum in this tier way. And again, this is people that are trying different things, but spectrum sharing is key and is going to be more and more relevant in the future in all different use cases. So it's good that we start to understand how we can develop frameworks which allow multiple technologies and regulators they're doing this because of course we didn't develop LAA in isolation. As you may know, ETSI brand developed this. Let's say ETSI brand that does not develop and they should not develop, of course, an actual spec, but ETSI brand sort of mandated and well, it's not formally approved, but is mandating some principles for coexistence and some principles on how to do the listen before talk scheme. Then each technology will fix the nitty-gritty stuff and do the detailed specs. But also the regulators, it's an important area in which they have to establish and clear rules for coexistence in this shared spectrum scenario, and strike a balance between not being too detailed, but at the same time giving important directions on how to the technology should work together. So ETSI is an important development in this big picture. So it's not, and we are fulfilling the ETSI requirements, by the way, with the LAA. So long answer, but it was I had to unpack several things.
Hi, Dean Bubley from Disruptive Analysis. Couple of quick questions. First off, have you given any thought to fixed broadband use cases for 5G? Because it looks like they may be the lead rather than mobile broadband. And the other question is any thought being given to coexistence the other way, for example, using Wi-Fi in license bands?
Okay. Always very provocative, Dean. So again, two different. So let me start from the first one. So I don't share your view that the main use case will be fixed broadband. I understand there is a significant development in one region about having this pre-5G and a fixed broadband use case for that. But I don't. This my personal opinion is not. I don't think we can call yet that as the main, just because it's early, we cannot call that as the main 5G development, and I don't think that will drive the main 5G standardization in general. That's a general answer to that. So in 3GPP we are going ahead, and fixed is not our main target, and I think fixed is not going to be the main market also when we start. They will start a little bit earlier with that use case in that region, that operator, fine, that's understood, and it's an important one. They have an important business case for that, fair enough. But I don't think that can be projected onto a successful initial thing. So at least I see it differently. But at least in 3GPP we are not focusing on that, and I don't think that will be the main thing. But in that, we'll see. That's the second thing is about extending Wi-Fi to license spectrum. So it's not for 3GPP, of course, to discuss, and why not? So I guess it's you should ask the same question to the IEEE groups. They've tried it in the past, because it's not like they didn't try it. If you remember, during the 4G time, they did this extend Wi-Fi to license, which was called WiMAX. I know that there are discussions right now whether they should do a submission to IEEE, to ITUR themselves. Of course, if they decide to do so, then it may entail the development of a licensed technology. But again, I'm just speculating, because it's not anyway my job title to discuss the IEEE evolution. But just to answer the provocative question with a I don't know if there is somebody from IEEE that wants to answer.
I'm not sure. I'll take one more question. Eduardo, please.
Thank you, Mr. Chairman. Good morning to everybody. Eduardo Marelli, European Space Agency. I say that I'm not an expert in IMT. I'm not an expert in standardization, so I apologize in advance for the silly question. But I'm not clear from your presentation if this famous deadline of March 2017 would allow us to have specs on the physical layer and on the operational scenarios that would be considered, that could be considered as final. So I got lost a bit into the various releases, and so I may have lost this information in it, but maybe if you could clarify. Thank you.
Okay, so just to be clear, the first, and you are talking about the first release of the new radio, right? The first release of the new radio, I don't know why it got in your question in March 17. The first release of the new radio will end on September 2018, as per current schedule. This is the date in which, in 3GPP, we call the SN.1 freeze. We freeze the specs and the SN.1 code, which is coding the protocols of the specification, the radio protocols of the specification, and implementation can start based on that, commercial implementation based on that. So the first release, it's as per current schedule, is going to end in September 18. So March 17, I think you referred to maybe this. I don't know.
Sorry, maybe I can clarify. Yeah. I was referring to the linkage with the activity in ITUR, and in particular TG51, or 5D towards TG51. So where this kind of information will be needed in order to be able to start the sharing studies related to agenda item 1.13. So I was wondering how stable you expect these parameters to be, since they will be used for the sharing studies.
Okay, and when so these are not really in my radar now. So that's really so what is the deadline for that development? So I have no idea.
No, here we're not talking about development, but rather about sharing studies.
Okay. Sharing.
So we need to know, and apparently we will know by March 2017. So in a few months, final physical layer parameters that would allow sharing studies with other services in the bands, in the frequency bands above 6 gigahertz, which are identified under agenda item 113.
Okay.
So unless these parameters are stable, the sharing studies would not be very significant.
Yeah.
If they are not.
So the only thing from our side, the only thing will happen in March 17 is we are going to start the normative phase for the first version of the NR, the new radio. So I would assume that many of these, the physical layer parameters, they will be understood by that time, but I cannot say that everything will be decided, because of course then there is the normative phase, which will run until mid-September, in which we'll define the details. So I don't know the exact sharing studies, and to date, it's not like we have a plan to share anything with this other discussion in ITUR, but we may. So if it's needed, yeah, we may share whatever we have at that point in time. But It's not in our radar. So it's on my radar, therefore it's not in our radar. We are not, at the time, we are not sending anything else. So if needed, it has to be raised in one of the future meetings if we need to share something else for these sharing studies. Yeah.
Okay, thank you, Dino. It looks like 5D is going to have a hard task to nail down those parameters to pass on to TG51. Well, thank you very much, Dino. Håkan, did you want to make a comment on that?
Yeah, yes, thank you, Mr. Chairman. So we are expecting, we have sent from Working Party 5D a liaison to external organizations on this aspect, and we are expecting some response for the next meeting on this, where we will develop the final parameters to be used in the sharing studies. Thank you.
Okay, thank you for the clarification there. So we'll try and move on very quickly now to our final speaker for this first session. This is Adrian Scrace from ETSI. Adrian's going to talk about the harmonised standards, and particularly with the relationship with the new radio equipment directive. Adrian, it's all yours.
Thank you, Steve. Good morning, ladies and gentlemen. What I've been asked to talk about is how 3GPP relates to ETSI, relates to the Radio Equipment Directive, which you might think is a rather strange story to tell, but if you want to place products on the European market and those products contain a radio, this is a very important story to tell. And actually, it's the first time we've actually thought about how 3GPP relates to ETSI, relates to the Radio Equipment Directive. So I think it's quite a timely piece of work that we give this presentation here. I'm conscious that a number of you are still clearing your inbox. I see a lot of people reading email. If you want to carry on reading email, that's fine. There are some key takeaway boxes that you'll see appear on the screen. You just have to glance up occasionally, look at the key takeaway boxes, and you'll get the main story. Building on what Dino has said, I'm also conscious that there are people in the room that don't know an awful lot about 3GPP and were perhaps a little bit bemused by some of the acronyms and abbreviations and things that you saw in Dino's presentation. So taking 2 or 3 steps backwards, a helicopter view of 3GPP, it is a standards activity that has a project coordination group, it has 3 technical specification groups, and it has 16 working groups. So to all intents and purposes, it sounds like any other sort of standards activity. But on the right-hand side of the screen, there are some key figures which give you some sort of dimensional facts about 3GPP. These are 2015 figures. It represents roughly 50,000 delegate days of work per year, a total of 40,000 meeting documents per year, of which 10,000 documents are changes to 3GPP specifications. This activity produces 1,200 specifications per release, and that work is done by 514 companies that come from 45 different countries, and they do this work on a sort of an 18-month cyclic basis. So just to give you some impression that this is not a small forum that sits away in a corner somewhere and does work, it's actually a standards factory. It's a very, very large monumentic activity, which is why it plays such an important role in the evolution of mobile. So how does 3GPP relate to the rest of the world? From an egocentric point of view, I've put 3GPP in the center of the screen because that's the easiest way to explain it. And because of its size, it is quite an influential activity. But it certainly should not and cannot do everything on its own. It's entirely dependent on the work of others. It makes wholesale reference to the work of other bodies. It liaises very closely with the other bodies. On the bottom of the screen, you will see the people who perhaps are the primary actors within this activity, and these are the standards bodies who actually form 3GPP and provide the infrastructure under which it works. Of course, we have ETSI in Europe. We also have 2 standards bodies in Japan, Arab and TTC, TTA in Korea, CCSA in China, ATIS in North America, and TSDSI in India. And it's these standards bodies where those member companies originate from to bring their intellect into the project to write these specifications. And it's those standards bodies that eventually submit this work back to the ITU in the form of reference material, which forms the basis of the IMT process, which Håkan explained very eloquently first thing this morning. So key takeaways then, 3GPP itself is not a legal entity. It is a collaboration between standards bodies. It provides technical specifications and reports which are then transposed and published by the standards bodies in their particular regions or countries. It cannot work in isolation. It's entirely dependent on work from other bodies to complete its task. If we look more closely at ETSI's role in this big story then, and in particular to 5G, ETSI has started a number of new activities in the last 12 to 18 months, some of which you will be familiar with, some of which you may not have heard of. I'm sure most people have heard of network functions virtualization, this concept of taking functions which today are performed by hardware and producing them in a software performable way. This is a cornerstone of work for the future evolution of 3G mobile networks. And a natural step forward from that was to develop an open source implementation of the management and orchestration element of NFV. Also mobile edge computing, millimetric wave transmission, pieces of work that have been ongoing for about 12 months or more now in ETSI and making quite good progress. One piece of work you may not be familiar with, next generation protocols. This is a new activity that started at the beginning of this year, having a rethink about IP and saying, well, actually IP was designed for fixed networks and we're trying to adapt them for mobile. What if we were to rethink IP and design it so that it was mobile friendly, but also useful in fixed networks? So having a drains-up analysis, if you like, of IP and its suitability for 5G and onwards. They have produced their first findings. It's generating quite a lot of noise. You will have seen quite a lot of press coverage about it. If you want to know more, I would recommend you go to the ETSI website and take away the free information that's available there. So there's lots of new activities, mobile broadcast convergence. You'll hear more about that later this morning, I hope, as well as a continuation of existing activities within ETSI, particularly on the use of the radio spectrum, sharing studies, the way you can share and licensed and unlicensed regimes. This is sort of business as usual for ETSI, but that continues also in a 5G context, including energy efficiency, which is becoming much more of an interesting subject, not just from an economic point of view, but from an environmental point of view as well, and the use of satellites in 5G. So just to illustrate then that there are many contributors to this 5G standardization activity. It can't all be done in one place. ETSI is developing a number of building blocks or cornerstones which will form the basis of that work. And then 3GPP will take the summation of all this work and specify a complete system description. So 3GPP is not just talking about radio interfaces, it is standardizing a complete system description, taking the work from other bodies where that is appropriate. Now, I'll make no excuse for showing this triangle that you've seen 100 times before, and no presentation is complete without it. But I like Håkan's works to say that the three corners of the triangle demonstrate the extremes. It shows the diversity of what it is we're trying to achieve with 5G. Likewise, the spider diagrams, you can't possibly have a presentation without these spider diagrams, but they are really useful to show the extremes of what it is we're trying to achieve. So if you are to achieve those extremes, no single technology is going to do that for you. So as Dino has amply explained, what 3GPP is in the process of doing is developing a new radio plus an evolution of the old radio, a new core network plus an evolution of the old core network. All of that cannot be done at once. The priority then is to develop a 5G system which, in the context of these triangles and spider diagrams, really concentrates on the enhanced mobile broadband use case first. So that's keeping 3GPP awake right now. That is the first priority, with some ultra-reliable, low-latency functionality, but not in its full-blown form. And later we will come to the massive machine communications work, because actually right now the 4G solution is only just getting traction and is doing quite a good job. So we don't really see the major driver that says massive IoT is the first priority for 5G. When will it be ready? When we've heard this 2020 deadline from a number of different places, why 2020? Well, I can find no real scientific reason why it should be 2020. It certainly wasn't derived from an analysis of how much work needs to be done and when can we do it by. We're sort of working back from this headline date. It does happen to coincide with some sporting events. It does happen to coincide with this idea that you have a new generation every 10 years, but there doesn't appear to be any science behind the date. It just happens to be a round, convenient number. But then if we look back, say, 3 years ago, operators were saying to the standards bodies, slow down, slow down. LTE Advanced is doing a great job. We really don't need 5G just yet. So we did. A year later, operators are saying, you've got to speed up, standardization's too slow. There is this operator rush, which is hard to fathom, but it's a fact of life, that there is now an operator race to be first. And you see every week in the press, operators saying they're going to be first, and then the next operator, no, we're going to do it 3 months ahead of them. So there is this rush which we have to cope with, not based on any real science or study. It's just commercial reasons, I suppose, that some operators do want to launch as early as 2018 in some cases. And then, of course, I guess it'll be 2017 by that one operator that really wants to be first. And this is why we see this sort of alliances being formed on the periphery of 3GPP, where certain groups of operators are getting together and doing their own thing ahead of the 3GPP timescale. They are committing to bring that work back into 3GPP. Only time will tell whether or not there is any difference between what the early adopters want to do and what 3GPP is doing. We just have to take note that these things are happening and there isn't much we can do about them. So then looking at the Radio Equipment Directive, what does that have to do with all of this? Well, I'm sure most people in this room are probably more knowledgeable about the Radio Equipment Directive than I am. But in essence, it replaces the Radio and Telecommunications Terminal Equipment Directive. It has a number of big differences, one being that it includes transmitters and receivers, whereas the former directive did not. And it covers equipment regardless of their primary function. So a washing machine that has a communications modem within it is now a radio under the Radio Equipment Directive. So whether you like it or not, your washing machine has to meet the essential requirements of the Radio Equipment Directive. So the key takeaway here really is that all 5G radio products, and these are not just those produced by ETSI or 3GPP, it could be produced by some third party. In the past it was the WiMAX Forum, for example. So anyone that wants to come up with a 5G proposal and place that on the European market will have to comply with the Radio Equipment Directive. And note that it is not just the transmitter they need to take care of, but it's also the receiver characteristics. Now, the jury is still out on what will happen if you want to place products on the United Kingdom market. We'll come back to that, I guess, in a couple of years' time. For the time being, though, Radio Equipment Directive prevails, and we need to take good note of it. So how does ETSI write standards that meets the requirements of the Radio Equipment Directive? Where we follow a very tried and trusted process where the European Commission says to ETSI, will you please, no, not will you please, you will write a standard which meets the requirements of this directive for this particular product. ETSI in turn then writes those harmonized standards. The European Commission publishes them in the official journal of the European Union, and we have a harmonized standard. So it sounds a very simple and easy thing to do. Looking beneath the cover, though, how that actually takes place from beginning to end, ETSI has a committee called the Mobile Standards Group, TCMSG. This group was created at the same time that 3GPP was created, on the understanding that things might happen in 3GPP that are not entirely in line with what we want to see happen in Europe. There might be some differences. And if there are those differences, who's going to take care of them? So it was this committee, the Mobile Standards Group, was created to take care of those differences. So if we see anything coming out of 3GPP, which we then want to use in Europe, and we find there is a gap or a difference, this committee is the place where that difference is filled. Now, historically, it very rarely happens, but it's there as a safety valve, it's there as an insurance policy in case we have to do work within Europe because we're not satisfied with the work that 3GPP has done. So historically, this group has developed harmonized standards for the RNTTE directive. It's done that for products coming from 3GPP, also from IEEE and from the WiMAX Forum. It has a joint task force which is specifically responsible for the development of these European norms, and it sort of takes its lead really from the IMT process. When there is a new IMT update, this committee jumps into gear and says, well, we better make sure that our harmonised standards are up to date then. So if we try and map this between ETSI and 3GPP, on the left-hand side we have ETSI technical committees, the Mobile Standards Group, which I've already mentioned, together with the EMC and Radio Spectrum Matters Group, ERM. They jointly work together in this task force, and they then work closely with the TSG RAN group, which Dino chairs, to make sure that these harmonised standards actually are fit for purpose. So this task force drafts the harmonised standards derived from the work done in RAN. It's imperative then that to get that work right, we have member companies who are active both in TSG RAN and in the ETSI committees. And we can note that historically administrations are conspicuous by their absence. That's a polite way of saying it. Basically, administrations don't really come to this activity. And that's one of the key takeaways, I think, from this presentation, that if administrations really care about how products are going to be placed on the European market, they should really be much more active in this activity. This I won't go through in any detail. It actually explains how this task force works. I don't think we need to go through that in detail here because we're running into the coffee break. Just to show that it is a very methodical, very well process driven mechanism to produce these harmonised standards. What should be included in a harmonised standard? ETSI has produced a guide, ETSI Guide 200336, which you can download from the ETSI website, which explains in quite some detail what should be included within a harmonised standard for the Radio Equipment Directive. I don't intend to go through the contents today. Suffice to say that we have a very clear understanding as to what should be in and what should be out. But then, having produced that harmonised standard, how do you get it approved and published in the official journal? It follows, again, a very well-structured process where the draft harmonised standard is sent on a public inquiry. So you have 90 days then to comment on the standard publicly. So we put it out in the public domain and invite people to tell us what they think of it. We also invite our national standards organisations in Europe to vote on it and tell us whether or not they think it's good enough to be published or not. If we receive no technical comments, it's immediately published. If we do receive technical comments, they have to be resolved, and we go back round another iteration of voting before we actually publish this harmonised standard. It's a process called ENAP, the European Norm Approval Process. You don't really need to know the detail, but what you do need to know is it takes a minimum of 144 days if all things go well, if there's a following wind and no one makes any comments. If people do make comments and things don't go so well, it takes a minimum of 294 days to produce this harmonised standard from the time that you have a stable draft available. After that, you still have to publish this in the official journal of the EC, which takes several weeks further. So it's a very complex process and it takes an awful long time. What if the harmonised standards are not available in time? What if we end up with early adopters wanting to put their 5G products on the European market and there are no harmonised standards in place? Actually, quite a realistic scenario, I would say, at this stage. We don't know yet when the first European operators will deploy, but it could well be ahead of harmonised standards being available. So ETSI has written another guide, 203367, which is a guide to the application of harmonised standards. Now, this can be used in the absence of harmonised standards to explain to your regulator why it is you think your product meets the essential requirements. If there are draft standards that are in the ENAP process, you can take those draft standards and use them and say, well, I've applied the draft and I comply with that draft, therefore I think I'm good enough. You can also say, I've used the ETSI guide and I've used that as the basis for my submission. And then notified bodies then can take this evidence and make an assessment about whether to allow you to place your product on the market or not. Of course, the harmonised standard route is by far the preferred option, but in this scenario where we know it takes at least 1 year to produce a harmonised standard, you may have to have a plan B, and there is a plan B, and it's quite well documented. Some conclusions then. 3GPP is preparing a complete 5G system description. That allows early implementation in 2018, full implementation in 2020, very well explained by Dino. ETSI is preparing significant building blocks which form the 5G cornerstones. ETSI's committee MSG and its task force will prepare harmonized standards to assist industry in demonstrating compliance with the Radio Equipment Directive. But we should note that it takes roughly 1 year from beginning to end to produce a harmonized standard. In fact, it can take quite a lot longer. So you need to think ahead. Industry and administrations need to think ahead about products being placed on their market, and will those harmonized standards be available in time. This is an iterative process, because once you have your harmonized standard, as Dino's explained, 3GPP is changing its work every 18 months. There's a new version. So you have to make sure that those harmonized standards are not only up to date, but also synchronized with the ITU IMT process. So finally then, industry must anticipate when they think 5G products are likely to be placed on the European market. They need to work back 1 year from that, at least, to prepare the harmonized standards if they want that to show compliance with Radio Equipment Directive. Thank you, Chairman.
Thank you, Adrian. A very busy time at the moment for ETSI getting all those harmonised standards ready in time for the deadline. Are there any questions to Adrian on that presentation? I see none, so thank you very much, Adrian. So we'll break for coffee. We're a little later than scheduled, so I would ask that we come back in 20 minutes. That will be at 10:40 for the next session. Thank you.